Hey guys, this video is going to go over graphing inverse functions. So we already know what an inverse function is and how to find an inverse function. Now we're going to look at the graphs of inverse functions and kind of see some special things about them. So let's start with this one. Let's say if I gave you this function, we'll do a quick review. How do I find the inverse of the function? So if you recall, remember our first step is we can change that to y equals 2x plus 3. And then if we're finding an inverse function, the x and y variable flip. So I'm going to change that to an x and over here to a y. Okay, now I'm going to solve for y. So I'm going to subtract 3 from both sides. So I get x minus 3 equals 2y. And then last step, I'm going to divide everything by 2. Divide this by 2. So I end up with y equals, I get x minus 3 over 2. All right, so my inverse function is x minus 3 divided by 2. Okay, I'm just going to box that. Okay, and then here was my original function. Now, we also learned how you can check to see if you did this correctly. So let's go ahead and do a quick check. All right, so if I'm going to check the function, I'm going to start by plugging in any number I want into the original function. So let's say I do f of 3. So I'm going to plug it in for x. I'm going to do 2 times 3 plus 3. Again, this was in my original function. I end up with 6 plus 3, which is 9. Okay, now I'm going to take that 9 and I'm going to plug it in my inverse function. So I'm going to go to my new function, and instead of x, I'm going to put a 9 minus 3 and then divide it by 2. So if I do that, 9 minus 3 is 6, divided by 2 is 3. Now you should notice when I did this, I'll just grab my highlighter, I started by plugging in a 3 and I got a 9. And in my inverse function, I plugged in a 9. I should have put a 9 right here, but I put a 9 in, and then I got 3. So I know I did it correctly. All right, so now I took those two functions that we just wrote, and I graphed them in decimals. So you guys can see my original one, 2x plus 3, is in blue here, and my inverse function to that is in red here. Now remember, inverse functions mean like they undo each other. So there's kind of some special things about these two lines that we're hoping that you notice. So the first thing I want to show you guys, that's kind of cool, and you guys kind of explored this already, is take a look at some of the points that are on my blue line, my original function. So I see these 3. So I'm going to start with this one. I see up 0, 1, 2, 3, or sorry, over 0, up 1, 2, 3. I'm going to put that in my table. So 0, 3 is in my original one. Another point is negative 1, 1, and you guys should be able to find that as I go. And then my other one I have with a big dot is 1, 5. Okay, so again, I was just looking at this blue line here. Now look at this red line, and we're going to see what we notice. So I'm going to start with this one. It looks like 3, 0. Okay, so I'm going to add that to the table over here. Another one, it looks like 1, negative 1. And another one looks like 5, 1. Again, all I did there was take these 3 points and list them right here on this table. Now, is there anything cool that you guys noticed between these two tables? And especially I tried to line them up. Look right across from each other. So in my first table here, or my first point, 0, 3, in my inverse function, it's 3, 0. It flipped them. In this one, in my regular function, it was negative 1, 1, and now it's 1, negative 1. And then it was 1, 5, now it's 5, 1. So this is kind of a cool thing about inverse functions with lines, linear inverse functions, is that the original coordinate, it flips. It becomes y, x. So it just flip-flops the coordinates. So that's one thing that's really cool about inverse functions. That's one way you can test to see if you did it correctly. Another thing that's kind of cool is take a look at the slopes of both of these functions. I want you to pause and find me the slope of both of those lines, and then what do you notice about their slopes? All right, I'm going to start with my blue line. My slope, it looks like, is up 2 over 1. Okay, so that one has a slope of 2 over 1. My red line looks like it's up 1 over 2. That one has a slope of 1/2. Now, they're both positive. I can see that they're both positive. So the slopes of inverse functions, and this is for linear ones, are just reciprocals. Now, a lot of you guys are going to be maybe think you need to write opposite reciprocals. They are not opposite. Remember, opposite means their sign changes. That's with perpendicular lines. These slopes are just reciprocals. So 2 over 1, 1 over 2, they're just flipped. All right, the last thing that I just want to point out when you have these, take a look at the y-intercept of my function. It looks like it was 0, 3. Now in my inverse function, it's a 3 comma 0, and now it becomes the x-intercept. So that's just kind of one other cool thing. All right, one last thing that I want to point out to you. So we are going to take a look at this line right here, y equals x. Okay, now in case you forgot from previous courses, this is just a basic line. It's got a y-intercept of 0, you can see it right here, and it's got a slope of up 1 over 1. This is called the parent function for linear graphs. Now, I took this line here, and then I still have my function and its inverse. Do you notice anything about these two lines compared to the green one? Does anybody notice anything? Now, I'm going to put 2 points on the graph and see if that gives you a little bit of a hint. Okay, so check this out as I put these on. What if I look at this one and this one and compare it to that green line, or this one and this one? What do you notice? Well, I actually can take this blue line, and if I reflected it or flipped it across this green line, it would land right here on this red line. So if I took this point here and flipped it across this line here, it would land right there. Another thing to check out with these, if you don't remember reflections from when you did them in 8th grade, is if I went like down 1 and over 1 here, down 1 over 1, you can see it's the same distance away. Same thing here. If I went from here right across here, you can see it's flipped. It's just reflected over that green line. Mirror image goes over here. But I could also use kind of slope to count. It's down 2 over 2, down 2 over 2. It would land right there. So the last cool thing about these inverse functions, this only works for linear ones, is that all linear functions, their inverses are going to be reflected across this line, y equals x. All right, I have one more thing I missed that I just wanted to show you guys. So let's take a look at these 2 blue points I just drew in. So obviously, if I'm looking, it's reflected across this green line. But when you're counting it, watch this time what happens. So if I want to get to this green line, it looks like I could go down 2 over 1, or I could go down 1 over 2. There's different ways you can count it. So I'm going to go down 1 over 2. Now, to get my reflection, I have to do the opposite and go down 2 over 1. Okay, this one up here worked out nice because the numbers were both 2 over 2, or down 2 over 2, down 2 over 2. But if I would have went down 1 over 1, 2, 3, then I would have to go down 3 over 1. So you have to go the opposite, basically the opposite slope if you're counting. All right, so now let's say that I give you a graph and I give you this function. I don't give you the equation. All I do is give you the graph of it, and I want you to find the inverse function to this line. Now, there are probably 3 or 4 different ways that you could do this, so I'm going to go through a couple different ways, and I'm going to try to do it on a couple different slides so it doesn't get too confusing. All right, so first thing that I could do is I could make a table of points for my function. Okay, so this is just one way that I could do it. So I'm just going to grab a few points. I see -1, 2, 3, -3, comma 2. Again, I'm just looking at my graph. I see 0, comma 3. I see 1, 2, 3, comma 1, 2, 3, 4, I think that is. And I see 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4, 5, 6, comma 5. Okay, so there's some points. Now, if I want to do the inverse graph, I actually know that an inverse function, the x and y values are actually just switched. Okay, so if it was -3, comma 2, it has to be 2, comma -3. You just have to flip-flop them. This one would have to be 3, 0, it'd have to be 4, 3, and it would have to be 5, 6. All right, so I just graphed it. That should be a straight line, but it's hard to draw on the iPad. So there's my inverse function, and I did it by just using points from the table. Now, a quick way to double check that I did this right is I could find the slope of both lines. So I can see the slope here is up 1 over 3, okay? So my other slope needs to be up 3 over 1. It still has to be positive, but it has to be the reciprocal, and these ones they do have reciprocal slopes. All right, a second way I could have done this was dealing with the slopes, like I just kind of showed you, and flipping the points as well. So I know this one is 0, comma 3. I know that's going to have to turn into 1, 2, 3, comma 0. So I'm just going to plot that right there. Now I also can count the slope. It's up 1 over 3. So I know my inverse function needs to have a slope of up 3 over 1. So from this pink point here, I can go up 1, 2, 3 over 1. I can go up 1, 2, 3 over 1, up 1, 2, 3 over 1. And there I have, pretend that's straight, my inverse function again. All right, a third way you could have done it was even just started off with writing the equation of that function. So the equation for this function, it looks like my y-intercept is 3. My slope is up 1 over 3, so 1/3 x plus 3. Now I could have just went through the steps of finding the inverse function. So I could have done it algebraically. So I could have switched the x and the y value, okay, and solved for y. Subtract 3 from both sides. I get x minus 3 equals 1/3 y. Okay, now this is one I wanted to show you guys. If you get to something like this, I can actually times this side by 3. Those 3's will cancel. And then I need to times this whole thing over here by 3. So I'm left with y equals 3, parentheses, then x minus 3. Now if I multiply that out, I'm left with y equals 3x minus 9. Okay, from there, I could go to -9, which is way down here. And then I could go up 1, 2, 3 over 1. Keep doing that. 1, 2, 3 over 1. Oh, good. I got my correct x-intercept up 3 over 1. Keep going. Okay, and then there would be my inverse function, and it looks exactly the same as it did on all of my other graphs. All right, the last way I could have done it is dealing with reflecting it over the line y equals x. Okay, so I'm going to, real quick, just draw in that line y equals x with my green pen. Okay, now if I want to reflect my original line over that line, there's a couple of different things I can do. So I'm going to start with this point right here, kind of in pink. Okay, if I flip it across this line, the coordinates are just going to change, or I can do some counting. Okay, I can try to get to this green line, so it looks like down 1 over 2, if I count kind of like that, down 1 over 2. I have to do the opposite then and go down 2 over 1, and it would end up right there. So I'm going to do that again, down 2 over 1. Oopsie, it would end up right about there. That's not a very good point, but end up there. Okay, let's go to this one. Again, I can try to get to my green line. It looks like down 2 over 1, 2, 3. I have to do the opposite, reciprocal. I have to flip it and go down 3 then. 1, 2, 3 over 2, put a point. Okay, maybe I do this one. Maybe I go, again, you can do it a lot of different ways. Maybe I go down 1, 2, 3, 4, and then over 1, 2, 3. Then I'm going to do opposite, go down 1, 2, 3, over 1, 2, 3, 4. There's my point. Okay, here is my line. Now a way to double check it is look at your slope. My slope does look like up 1, 2, 3 over 1, which is good because this one was up 1 over 3. So I just showed you a lot of different ways that you can look at functions and how they relate to each other. So hopefully you guys, after watching this video, you can find an inverse function. You know what a table of points should look like for an inverse function, and you know what the graphs of inverse functions should look like as well.